Hi everybody. Can you believe we are at our last lesson? Oh my goodness, 11.7. Proportional segments between parallel lines. Very last lesson of Unit 12. Next week will be review, test, catch up, makeup days. That's it. So here we go. Let's finish strong. We're going to jump right into the conjecture here in 11.7. And basically what it says, go ahead and draw a triangle with me. It says that if you have a triangle and you take a line and you run it through so that it's parallel to one of the sides. Okay, so let me put that in there. And I'm going to put my parallel markings back on there. So if you have this, notice it breaks these other two sides into two pieces. Let's just label those A, B, C, and D. It divides those two sides proportionally, meaning I can write this one of two ways. Either A over C, so look where I'm going kind of across the triangle here, is the same as B over D. Or we know we can always rearrange these. I could also go along the sides of the triangle. So A over B equals C over D, whichever way you'd like to set it up. What we wouldn't want to do is have something like A over D, right? We know not to jumble them around that way. Okay, so this says if you have parallel lines, then it divides the triangle proportionally. The converse of that is also true, and we'll see an example towards the end of the lesson that uses that. So if you know that these ratios are equal, you could say, oh, these must have been parallel then. Okay, so I think this is actually sufficient as long as you have the diagram and the proportions. I'm not going to write out the conjecture. It's a pretty lengthy, wordy conjecture. I think that sums it up pretty nicely. So let's actually just jump right into an example here. Sorry, I'm flipping through my papers here. Okay, so here's our first one. Go ahead and take a second and copy that down if you need to. So we are told EO is parallel to LN. Please make sure you know that before you try setting up any proportions. So here's kind of the most straightforward example that you could see. I could say 36 over 48 equals y over 60 and solve that proportion for y. I could also go, so that's fine, you can do that and get an answer for y. I can also, let me just show you again, we can go across the triangle here, so I could say 36 over y equals 48 over 60. In either case, let me solve both of these again, just as a little reminder what happens when you do this cross multiplication. When we do 36 times 60, oops, sorry, use my calculator here. 36 times 60, 2,160. So look at this product that we get from cross multiplying here. So this product is 2160. This product is 48y. The same exact thing happens over here. Even though I jumbled around the proportion, I still get the same product, right? 36 times 60. There's that 2160 again. This direction, 48 times y. So I get the same exact thing. Okay, so we divide by 48. In either case, whoops, 2160 divided by 48, we get y is equal to 45 units, whatever the units might be. Okay. The next thing we're going to do, we're just going to take this one step further. Oops, I don't have the statement here. I lost it. But let's say that these three segments now are parallel. And we could put a fourth, a fifth, a sixth in there. It does not matter how many we throw in there. This is called just the extended parallel proportionality conjecture. Those proportions, those segments are proportional as well. So I could say 21 over 42, do you see where I'm pulling those from, is the same as 35 over x. And that's the same as 28 over y. This is kind of silly how I'm writing it here. Of course, we wouldn't work with all three of these fractions at once, but you could use two at a time to solve for x or y. So maybe I want to use just these two to start and solve for x. Okay, so let me do that. Actually, if you notice here, do you notice this? 21 over 42, that's 1/2. So 35 over x, that's also 1/2. X would have to be 70. I don't know if you notice those things as you're kind of going through solving for them. Similarly here, and so now I would use 21 over 42 with 28 over y, and I'd have to double y to keep that same ratio, so y is 56. Okay, you can also still go along the sides of the triangle, so I could do 21 over 35 equals 42 over x. That same rule applies there. Okay, let me do one more here with you because there's something that did not come up yet that we need to be aware of. This is by far the most common mistakes we're going to see in this section. So if you look at number 1, it says these are parallel. So we know it divides these proportionally, but notice it's not doing anything with these pieces over here that we just saw a minute ago. What it's using is this piece of, almost as if this were its own little triangle on the top. So we've got like this full side of the triangle being brought in now. So if I wanted to do this, let me actually show you a proportion that is wrong. And you might be a little bit surprised initially, but we'll talk through what's going on here. So if I say 4 over a, it's really tempting to do 12 over 20. But I want you to just study that for a second. Look at that diagram. Do you know what the problem is there? So let's say that I do think of this as one little triangle. These are actually similar triangles. We could go through and prove that angle is in there. So I've got that red triangle and then this big, let's make it yellow triangle here. So 4 and A are complete full sides of that smaller triangle, right? Little side over little side. 12 is just a piece of that big yellow triangle. I don't care about that. What we actually want is this whole thing, which is 16. Okay, so this one is no good. If you're going to work kind of within the triangle, sort of go inside the triangle here and use this full side, I need 4 over a equals 16 over 20. Okay, 4 over a equals 16 over 20. A ends up being, I think, what is that, 5 for this one. Okay, so watch out, that comes up in 2 and 3. You'll have to think about that. Okay, and then 8, you are using the converse or testing out the converse here. So they want to know, are these lines parallel? So you just have to see, are they the sides divided proportionally? And then in number 9, you can use the given pair of sides, the ratio that you have, to find your missing side. You'll just have to set up 2 different proportions for that. Okay, so go ahead and try these on your own. I posted the worksheet on the Google Classroom if you would like to print it out. Otherwise, you can kind of, I'll scroll through and then you can just copy them down, and I'll pause in a second here. Please come back. I'll go over the answers with you when you're done. Okay, so here's my work for number 2. We did 1 together. 2, the same thing happens here. So if you're going to use 15 over 20, we have to do the full side over the full side. So 25 over b. And just a note here, I didn't mention this in number 3, but there's no reason to use 15 over 10 here if you're going to be using these full sides. So 15 over 10 equals 20 over b, that doesn't work either. So make sure you got 33 1/3 for that one. If not, see if maybe you used a 10 in there. We don't want to just be using 10. Okay, and then number 3, a little bit of scratch work here. This one was a little more challenging algebraically. So setting it up is just the same, right? So full side over full side, 60 over 40. But then this full side is 60 plus c, or c plus 60, which is fine. When you set that up, you just have to realize that it's a little more work in solving that proportion for c. So you've got to cross multiply, you have to distribute, and then eventually get c by itself. So check your answer for that one. That should be 45. Okay, number 8, we want to know if the lines are parallel, so we want to know, is this a true proportion or not? So remember, when you're working with these, to figure out if they're equal, you just literally plug them in your calculator. Get a number for this, get a number for this, just make sure they're exactly the same. Number 9, just 2 separate parts here. So notice I circled the 2 and the 3 because that's the pair of pieces that I already had. So I did 2 over 3 equals 4 over m. You certainly could have a different proportion than me. That's okay. And then again, I used 2 over 3 equals 3 over n. I like to just use this same one over and over again, because if for some reason I made a mistake finding m, and then I try to use it to find n, well, now they're both wrong. So I always like to stick with my given information if I can. Okay, same thing here in 10. The number's just a little larger. You could see my work here. Let me get that out of that little watermark. Okay, so I used 10 and 18 as my one kind of initial constant ratio all the way throughout, and then find W and X, and there are your answers again. Okay, that's it, guys. We did it. Oh, we survived. Okay, so next week, remember you actually don't have school. Let me make sure I'm thinking through this correctly. Is that Tuesday on the 2nd? So Monday, I'll give you the review. You'll have Monday. If you need to do some of it Tuesday, you can, but there's no new assignment for Tuesday. Wednesday, we'll have our review day where you check the answers, ask me questions. We'll do a Google Meet. Hopefully I see a bunch of you since it's our last one especially. And then we'll have our test on, what does that put us on, Thursday. Okay, have a great day. Have a great weekend.